All right, in today's video we are going to be talking about paramagnetism and diamagnetism. And essentially magnetism, the most common element that it responds to a magnetic pole or a charge, is iron. I believe nickel as well. And but those are not the only substances that respond to a magnetic field. There are so attracted or bothered by a magnetic field, paramagnetic. Diamagnetic, it's not. So diamagnetic, not impacted by magnetic field. All right, and basically, in a nutshell, it has to do with the d orbitals and whether they are have unpaired electrons or not any unpaired electrons. So remember, the d orbital is that 5 circles, 1, 2, 3, 4, 5. So an example of paramagnetic, kind of extremely paramagnetic, would be something like that, where they're all half full. If you have some that are half filled, then it's still going to be paramagnetic, but not to the degree of like iron or something like this. So an example of diamagnetic would be if they're totally empty. They don't have any half-filled suborbitals. The other example would be it's totally filled. So those would be the two examples of diamagnetic. And then, so extremely paramagnetic, extremely diamagnetic, and then you have combinations in between. And I had this really cool demo. If you're interested, I could do a video of it tomorrow. I think I will, or sometime this week. I got unfortunately a meeting. They give us this planning time, and then they plop meetings in there. It's like, that defeats the purpose. Yeah, I'll do a video, and basically I hold a supermagnet up to various chemicals that have ions, transition metals in them, and we can see that they're actually attracted slightly to that supermagnet, but of course some of them are not, because they're more diamagnetic. That's paramagnetism in a nutshell. Can anybody say paramagnetism 10 times real fast? No, neither can I. All right.
You got it.
Oh, Dobson's got it? All right, let's hear it. Look at that.
Let's go!
Dobson's good. All right.
That was not 10 times.
Good.
Tommy, get out of here. Get Tommy out here. It's class, get out.
All right. Let me find that worksheet that I would have normally gone. What's that? Oh, here it is. Yeah, it's PDF. Fortunately, I was trying to convert it to a Google Doc, and it wasn't being friendly. Okay. Oh, darn it! I don't have the chemicals in there. All right. I remember manganese was one of them. I believe it was manganese 2+. All right, let's just do this from memory and kind of just do a quick example. So here's manganese 2+, and we want to see if this is diamagnetic or not. So all of the intertransition metals aren't really of concerns when talking about paramagnetism. It's basically the outer d orbitals that are important. So now we got to figure out, where's that periodic table? Periodic table. Figure out where manganese is. It's somewhere in the 3D area. Do it. All right, here it comes. All right, manganese looks like it's number 25. All right, argon. This is in the way again. All right, so I'm going to put argon in brackets, and after that, it's 1, 2, 3, 4, 5. I'm just going to make a note that it's in the 5. Hey, it's manganese 2. Well, let's get to that later. So argon is going to be 4s2, 3d, 5. All right. 4s2, 3d, 5. But we said it was manganese 2 plus, so we got to take 2 electrons out of there. No, we don't take it from the 3d. We got to take it from the 4th, the outermost energy level. So technically, this is going to be written as argon 4s0 or just 3d 5. All right, so let's do the orbital filling diagram for this one. There's going to be nothing in there. And then we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, because we got to follow Hund's rule. Fill in each suborbital with 1 electron before we can pair them up. And the question is this paramagnetic or diamagnetic or just slightly paramagnetic? Do you think it would kind of be attracted to the magnet or not at all, or maybe a little bit?
Paramagnetic.
Paramagnetic, you got it. Because it's got a lot of unpaired electrons in that d orbital. So manganese 2 plus, from my memory, is one in that demo, which maybe I'll make the video tomorrow, otherwise the next day, where it'd be attracted to the magnet significantly, kind of like iron's attracted to a regular magnet. 4s0 because we pulled out 2 electrons because it's 2 plus, so it's an ion. And we pull them from the 4th energy because it's further out than the 3rd energy level. If we did pull 2 out from the d orbital, it would still be paramagnetic, but not as paramagnetic as this conformation. Let's see, do you guys want to do another example or call it a day on paramagnetism?
One more.
All right, you read my mind. I was thinking that. So, I was thinking about doing copper. That was one of the examples. I just don't remember if it was copper 1 or copper 2. So, why don't we just do zinc 2 plus? All right. All right, zinc 2 plus. So this is zinc. I think it's got 20 some protons. Let's see. Nope, 30, 10 off. All right. So we're going to do argon again in brackets. And we're going to go to 4s2, 3d, all the way 10, filling it up. 4s2, 3d, 10. But remember, it's zinc 2 plus the ion, so we got to pull 2 electrons away. Do we pull it from the 3rd or the 4th energy level? Furthest one out. So this is actually going to be argon 4s0, 3d, 10. And if we were to draw the orbital filling diagram, 4s0 would be empty. And we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're done. And the question is this paramagnetic, diamagnetic, or somewhere in between?
Diamagnetic.
Diamagnetic, because we have no unpaired electrons in this one. So this is definitely diamagnetic. If I were to put a supermagnet up to it, it would do absolutely nothing unless I bumped it or there's air currents. All right. That's it. So paramagnetism is when there's unpaired electrons and it does interact with a magnetic field. Diamagnetism is when you have no unpaired electrons and they do not interact at all, not whatsoever, with a magnetic field. And then you can have things that are slightly paramagnetic. Okay. All right, that's paramagnetism.